Good evening, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to apply differentiation in what we call motion. And of course we have had in the previous slide that we can apply differentiations in motion or in the subtopic of motions of a particle in a straight line. And this is just what we are going to do, because we have been identifying some of this relationship, and keenly we have seen that if we are talking about distance s, if you want to talk about velocity v, and finally acceleration a, this is distance s moving to velocity v, and finally to acceleration a. We know that v is the distance, the change of distance with time, or v, which can also be known to be the speed, is actually v is speed over time. Velocity is the speed divided by time. And we also know that acceleration is the change in velocity with time. So in other words, if you want to get velocity, we have to talk about change in distance over the change in time. In other words, we have to differentiate a function of the distance with respect to time. And if we want to get acceleration, we have to get the change in velocity over the change in time. So for us to calculate the acceleration, we have to have dv or dt as a function. So in this case, let us keep this in mind. We shall use it extensively. A bicycle travels along a straight line. Its displacement s meters from its starting point O after time t seconds is given by the equation s is equals to 4t plus 3t squared minus t cubed. That is the equation of displacement given by this. After a time of 2 seconds, find the bicycle's velocity. After a time of 2 seconds, find the bicycle's velocity in meters per second. Of course, as we have explained, for us to get the velocity, we have to have ds dt. We have to differentiate the function of the distance with respect to t. So v is ds dt, whereby we just differentiate this, which is 4 plus 6t minus 3t squared. And there we are. So for us, this is how we can calculate velocity. So we are saying after a time of 2 seconds, and after a time of 2 seconds, of course, we know t is equals to 2, because after a time t seconds is given t. So t is 2 there, 2 seconds. So velocity after 2 seconds is going to be 4 plus 6, 2 minus 3, 2 squared. And basically this is v is equals to 4 plus 12 minus 12. And that is it, because this is 2 squared, 4 times 3 minus 12. 12 minus 12 is 0, and therefore we can easily say velocity is 4 meters per second after time 2 seconds. That is part A of that question. What about part B of the same question? You realize that part B is asking about acceleration. After a time of 2 seconds, find the bicycle's acceleration. And we know acceleration is the difference between, or the differential of dv dt. But what is v in this case? Our v is actually the first derivative, which is 4 plus 6t minus 3t squared. So acceleration, which is dv dt, is going to be, this one is a constant, is going to die, is going to be 6 minus 6t raised to power 1. After 2 seconds, after 2 seconds, of course, we all know that t is equals to 2. So substituting in this one, we are going to find that we're going to find acceleration is 6 minus 6 multiplied by 2, which is 6 minus 12, which is negative 6 meters per second squared. Those are the unit of acceleration. Negative 6, of course, you can see you are decreasing, on the speed is decreasing. So the bicycle in this case is slowing down. The bicycle in that case is actually slowing down after 2 seconds. So that is it. Thank you, and let us meet in the next video.